Hello and welcome to G Fun Facts Online, the show that unpacks the science and technology shaping our world. Today, we're talking about something you use every single day but probably never see. It's the invisible engine behind your search results, your social media feeds, and the incredible generative AI tools that have taken the world by storm. We often think of AI as something abstract, a ghost in the machine. But it is intensely physical. It lives and breathes on silicon. And right now, a global arms race is raging, not for territory, but for the tiny, incredibly complex computer chips that power artificial intelligence. This isn't a battle fought with soldiers, it's fought with engineers, with multi-billion-dollar fabrication plants, and with mind-bendingly small transistors. This is the great AI chip war. For years, one name has dominated this battlefield: NVIDIA. If you're a gamer, you know them for their graphics cards, or GPUs. It turns out that the same architecture that makes video game landscapes look so realistic is also perfect for the parallel processing required to train massive AI models. NVIDIA saw this opportunity early and capitalized on it brilliantly. They didn't just build the best hardware, they built the software to go with it. Their CUDA platform is a programming model that has become the industry standard. It's like they built the best race car and also the only gas station and mechanic for 1,000 miles. This software moat has made it incredibly difficult for anyone else to compete. With their latest monster chip, the Blackwell B200, NVIDIA has only extended its lead. But when a king sits on a throne this valuable, challengers will inevitably rise. And the first major contender is a familiar name: AMD. For decades, AMD has been the Pepsi to NVIDIA's Coke in the GPU market. Now, they're bringing that rivalry to the AI arena. Their weapon of choice is the MI300X accelerator. It's a beast of a chip, designed to go head-to-head with NVIDIA's best. While it might not beat NVIDIA on every single metric, it competes fiercely, especially in areas like memory capacity, which is crucial for running the largest AI models. By offering a viable alternative, AMD is cracking open the door that NVIDIA had sealed shut, giving AI companies a crucial second option. Then there's the sleeping giant, Intel. Intel, the company that for decades defined what a computer chip was, is now fighting a war on two fronts. First, they're designing their own AI accelerators, moving from their Gaudi line to a new architecture called Jaguar Shores. They are aiming to create not just a single chip, but a complete system-level solution for AI data centers. But their second front is perhaps even more ambitious. Intel wants to become a foundry. A foundry is a company that manufactures chips for other companies. Instead of just making their own designs, Intel wants to make chips for everyone, including, potentially, their own rivals. This is a massive strategic pivot, an attempt to reclaim manufacturing leadership from Asia and compete with the current king of foundries. But the established giants aren't the only players. A new and powerful faction has entered the fray: the tech titans themselves. Companies like Google, Amazon, and Meta realized that they were spending billions of dollars on NVIDIA chips. They also realized that their AI needs were very specific. So they asked a simple question: why don't we just build our own? Google was the pioneer here. Years ago, they began developing their own custom chip, the Tensor Processing Unit, or TPU. It was designed from the ground up to do one thing and do it incredibly well: accelerate Google's own AI workloads for services like search and photos. Their latest custom chip, called Ironwood, continues this legacy, optimizing performance and cutting costs for their massive cloud empire. Amazon Web Services, or AWS, the largest cloud provider in the world, followed a similar path. They developed two distinct lines of chips: Trainium for the heavy-duty work of training new AI models, and Inferentia for the less intensive but much more frequent task of running those models, a process called inference. By offering these custom chips to their cloud customers, they can provide AI services at a lower cost, challenging NVIDIA's dominance from a different angle. And of course, there's Meta. The company behind Facebook, Instagram, and WhatsApp needs enormous amounts of AI power to run its recommendation algorithms, moderate content, and build its vision for the metaverse. They've developed their own custom solution, the Meta Training and Inference Accelerator, or MTIA. For these tech giants, building custom chips is about control, efficiency, and cost. It's about tailoring the silicon perfectly to their software, creating a synergy that off-the-shelf chips can't match. This brings us to the final, and perhaps most critical, players in this global drama, the foundries. These are the companies that possess the almost magical ability to turn designs into physical silicon. At the absolute top of this mountain is TSMC, the Taiwan Semiconductor Manufacturing Company. TSMC is the world's master chip maker. They manufacture the most advanced chips for NVIDIA, for AMD, for Apple, for basically everyone who wants to be at the cutting edge. Their manufacturing prowess is so advanced and so concentrated in one place that it has become a major point of geopolitical tension. The entire AI revolution, in many ways, runs through their factories. Close behind, Samsung is pouring billions into its own foundry business, trying to close the gap with TSMC and offer a compelling alternative. And as we mentioned, Intel is also throwing its hat in the ring with Intel Foundry Services, leveraging its long history in manufacturing to try and win back customers. So what does this all mean? We are witnessing a Cambrian explosion of new hardware. This competition is driving innovation at a breathtaking pace. Chips are becoming more powerful, more efficient, and more specialized. At the same time, this intense rivalry, tangled up with national interests and supply chain security, has all the makings of a new technological Cold War, where access to the most advanced silicon is a key strategic advantage. Whether this era ushers in a golden age of explosive innovation or mires us in a dangerous and destabilizing technological Cold War, or, most likely, both, remains to be seen. The future is unwritten, but its code will be processed on the silicon being forged in the crucible of this great arms race. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another fascinating corner of our world.